Well, in 3300, when we developed an equivalent circuit for a transmission line, like the one here, and here's a whole series of them, we applied Kirchhoff's current and voltage laws, KVL and KCL, to the equivalent circuit, and we ended up with what are called the telegrapher's equations, which are shown here. In these equations, the distance along the transmission line is z, and time is t, and the transmission line is represented by its RLGC parameters, which you can see here: R, inductance, capacitance, and conductance, per unit length. That's what the apostrophe there means, per unit length. Each telegrapher's equation is a first-order differential equation with respect to both space and time. And note that these are simultaneous, or they're coupled differential equations, because they involve the same unknowns. We have v and I in both equations. So they have to be solved together at the same time. So looking at these two equations, there is one major issue we have with solving these equations using a computer. So I'll say here, major issue, one issue, with solving using a computer. Solving with computer. And what do you think that might be? Let's think about this for a moment. Certainly we can store values of G prime and C prime and so forth, and how they might or might not change with the length of the transmission line. And we can also store voltages and currents in the computer. So look through these terms and see if you can spot what the issue might be if we want to program this into a computer.